Hi, my name is Darren Patey. Today I'm here to talk about how to measure flow meter readings in your community pump house. Municipal water distribution systems present a challenging operating environment. The measurement and monitoring of water flow to the distribution system helps to ensure system reliability. The collection of flow monitoring data will provide an operator with vital information pertaining to the volume of water used on a daily basis. Consistent monitoring of water flow will indicate times of peak flow in a distribution system and will also indicate if leaks are an issue in the system. In addition, flow monitoring will assist in the protection of the distribution system components such as transmission mains, distribution mains, service lines, valves, and hydrants. Flow meters can also be used to control chemical addition systems such as hyperchlorination systems and gas chlorination systems. In order to measure or calculate the flow rate of water in a distribution system, an operator will need an existing flow meter or to have a flow meter installed. Various types of flow meters are available for use in the water industry, including mechanical types such as paddle wheel and turbine flow meters. There are also electromagnetic and ultrasonic type flow meters. Paddle wheel flow meters are mechanical flow meters and are easy to install and operate, resulting in a very low overall cost. The paddle wheel rotates as the water flows through the meter. The rotational speed of the paddle wheel is proportional to the velocity of the water and is used to calculate the flow. The majority of paddle wheel flow meters currently in use are a saddle-mounted configuration. These are commonly installed on small drinking water systems. Turbine meters have rotors or propellers that are turned by the flow of water through the meter. The rotational speed of the rotors or propellers is proportional to the velocity of the water and is used to calculate flow. The turbine meter is best suited for measuring flow in a distribution system with continuously high flows. The propeller meter may be installed within a section of pipe or it may be saddle mounted. Electromagnetic meters are an electronic flow meter, often called the mag meter. A magnetic field is generated and channeled into the water flowing through the pipe. The flow of conductive water through the magnetic field will cause a voltage signal to be sensed by the electrodes located on the pipe walls. When the water moves faster, more voltage is generated. The voltage generated is proportional to the flow of the water. Electromagnetic water meters should not be used on systems with low conductivity water. Ultrasonic meters contain sensors which are attached to the outside of a pipe. Sound pulses are sent alternately across the pipe in opposite diagonal directions. The frequency of the sound changes with the velocity of the water traveling through the pipe. The velocity of the water is used to calculate the flow. Electromagnetic and ultrasonic flow meters are becoming more commonly used in the water industry because of their high level of accuracy and due to the fact there are no internal moving parts. Because of this, less maintenance is required. Each type of flow meter will have specific installation requirements. Flow meters require undisturbed flow upstream and downstream of the meter. The length of straight pipe required will be specific to the type of flow meter. Also, some types of flow meters need a minimum amount of flow in order for them to function. Therefore, it is very important that the distribution system characteristics are considered when choosing the type of flow meter to be installed. There are two main ways for an operator to monitor and record flow data. They can either read the flow data directly from the register on the flow meter, or the flow data can be recorded remotely through a SCADA system. When monitoring flow rates from the flow meter, there is either a register mounted directly on the meter or there is a wall-mounted display. Most flow meters will display an instantaneous reading and a totalizer reading. Instantaneous flow, or rate of flow, is the volume of water flowing through the system over a specific period of time, typically measured as US gallons per minute or liters per second. The instantaneous flow will fluctuate throughout the day, with peak flows typically measured in the morning and early evening. Totalizer, or the total flow reading, is the total volume of water that has passed through the meter. Total flow readings are typically measured as a running total. Therefore, the total flow number may represent the volume of water that has passed through the meter since it was installed. The totalizer number can also be reset by following the manufacturer's instructions on how to do so. It is important to read and record instantaneous and total flow readings on a daily basis. These recorded values will provide a flow history of the system and will allow the operator to determine if the system is experiencing any abnormal flow events. Reading your meter can help you identify leaks in the system and track pumping costs. When recording flow rates on any flow meter, it is important to know the unit of measurement for the flow meter. Some meters measure flow in imperial gallons per minute, US gallons per minute, liters per minute, or cubic meters per minute. This is usually indicated on the meter or specified in the operations manual supplied with the meter. If the unit of measurement isn't indicated, contact the supplier of the meter. Flow readings can be converted from one unit of measurement to another using a conversion factor. You may need to convert flow from one unit to another if you are doing any secondary calculations, like determining your chlorine dosage. Always note the unit of measurement from your flow meter. When monitoring and recording flow rates directly from the flow meter, the operator should visit the pump house on a daily basis. If possible, the operator should visit at the same time each day. The operator should record the instantaneous flow and total flow readings on a log sheet. Template forms are available from the Department of Municipal Affairs and Environment, or you can create your own form. Along with the flow data, the operator should also record the date, time, and any issues with the system that may impact the flow, such as a known water main leak or if the distribution system was flushed that day. The operator should also use the total flow readings to calculate the volume of water that flowed through the system on a daily basis. To calculate the daily flow, take the total flow reading for today and subtract the total flow reading from the previous day. This calculation will only be accurate if the total flow readings were recorded at the same time each day. If total flow readings aren't available on a daily basis, the average daily flow can be calculated by taking today's total flow reading, subtracting the previous total flow reading that was recorded, and dividing by the number of days between the total flow readings. Calculating the daily flow is vital information for a water system operator and can help in identifying issues in the distribution system that may contribute to abnormally high flows, such as distribution system leaks or unauthorized use of the water system. For additional training on flow meters, contact the operator trainer for your region.